Now let us try to understand the multiple views of a platform. So the platform is somewhat like this. I'll modify the platform a bit later. Right now let us see the basic outline of the platform. So suppose the platform is what you can see here. Suppose this is the platform and you are watching from the front side X, and if you try to project the corners of the platform, you can see the platform somewhat like a trapezium, isn't it? So you can see something like a trapezium. That is the view of the platform. Important is the top view. Top view, you can see surface A of the platform. You can also see the inclined surface B and C on the other side. So when you project the sides of the platform like this from here, okay, so you can see the in between surface A. So surface A will look like this, isn't it? The inclined surface will be seen apparent. Apparent means reduced. So the surface B will be seen somewhat apparent. Can you see surface D? Answer is no. Vertical surface cannot be seen from top, but it will be seen as a line, and that line we already drawn. Same B is on the other side also. So here also we can see the same surface on the other side. So that is how you can see three different surfaces in the top view, where A is of the true length, true means exact length, whereas B and C are apparent length, which means reduced length. Now an important thing what needs to be discussed is, suppose within this what I can say is that within this platform, if you make some sort of cavity, so if I make a cavity like this, let us cut the platform, and you know that in engineering graphics or in any object, whenever there is a change of surface, an edge has to be there. So you can look here, two lines are meeting, so one edge has to go inside, the third edge. From here, three lines are meeting here, so the line, one edge has to go inside. From this corner there are two edges, the third has to go inside. So there is an edge going inside. Now if you carefully look at these lines, and if you try to analyze what I'm going to show, suppose there is a vertical surface, and if you draw three lines, so in the top view, can you see these three lines? Answer is no, because you can see only one single line, that is the projection of this surface will be seen as a line, isn't it? But suppose the same thing, if I show on an inclined surface, if I draw three lines like this, then what is the top view now? So suppose there is an inclined surface, okay, and if you look at this particular portion of the top view, and if you extend all these lines up, you can see a reduced rectangle, isn't it? You can also see these three edges, but that will be seen apparent, means small, reduced. So that is how the view appears like. So in a nutshell, I want to discuss is what I want to discuss is, anything drawn on an inclined surface, anything drawn on an inclined surface will be seen apparent. Same thing is applicable here also. See here there is an inclined surface. Can you see that? So within this inclined surface there is a slot which is being cut. So this B surface will be slightly modified, and if you try to project these two corners, you will somewhat get a reduced or an apparent shape of the object here. See, it will be somewhat like this. See, in between there is a discontinuation of line because there is no edge over here. So you can see the edge over here like this. Now same thing is the replica on the other side, because the object is symmetrical. So here also you'll find that the object is symmetrical. So you'll get this kind of surface. Now very important thing we are going to discuss here. What is that? So in the top view, orthographic is nothing but projecting parallel rays of light. So when you project parallel rays of light and when you extend this down, some part of this surface will be seen. In other words, you can see this edge up to what level, you know, up to a ray which is perpendicular with the ground. So you can see this edge, what I shown by dark. You cannot see the remaining edge. Again you can see on the other side. So here from this corner, some portion of the edge will be seen. Then it becomes hidden because you cannot see. Again on the other side you can see some portion. Yeah, similarly, this edge is on both the sides. So here also you can see this edge up to some extent. Then you cannot see. Then again you can see up to some extent. So just to clarify it, this surface actually is an inclined surface downward. So some portion of this surface can be seen, and that is this one, what I'm highlighting. Okay, so this important thing what I wanted to make you realize is, whenever you cut anything on an inclined surface, you can see some of its apparent shape in the top view. Now carefully look in the front view. So you can see that this point is 1, for example, suppose change of surface, this is 2, second change of surface, third and fourth. There are 4 points what I marked, and for any object, whenever 2 lines meet, a corner is formed, and from that corner there is an edge going inside. So you cannot see this edge passing through one in the front. So look in the front side, you cannot see this edge. So for that you need to draw a hidden line like this. Similarly, from edge number 2 you cannot see the edge passing inside. So this is for edge number 2 hidden line. Edge number 3 is in line with this another edge. So here you'll find the third edge as hidden. And last, this fourth one overlaps with the basic bottom edge. So these are the various views what you can see from the front and top. So why I have shown you this, because we need to reflect the same drawing while preparing this diagram. Okay, so starting from the front view, let us draw the platform now. So this platform is 90 millimeter length, 8 mm is the height up till here, and then inclined surface. So you can very well see that this length is not given, but this length, it purely measures with the diameter of the cylinder. So if you look at this cylinder diameter, it is in line with this diameter, that is 50. So this diameter is 50, and even this length is 50. Okay, so this length is 98 millimeter and the above one is 50. So we need to draw this front view of the platform here. Okay, so you can see in this diagram also, this trapezium type platform, we need to show it here. So see, 50 is already ready with us. Now we need to draw the bottom edge, that is 90 mm. So here we will draw an edge of 90. We need to raise this by 8 mm height. So the platform is 8 mm high. So from here 8 millimeter, even here we need to raise this by 8 millimeter. And then if you join the inclined, the platform gets ready. So I'm joining the inclined line over here. Okay, so that is how the platform is ready for me. Now apart from this platform, as I discussed before, there are few hidden lines within this platform. Let us see what is that. So if I enlarge a little, when you look in the front direction from here, you cannot see, look at this corner. From this corner there is an edge passing inside. Where this is this before that, is this 9 or 6? How to read? For some student it might be 6, some it might be 9. So you have to follow this ISO standard. Dimension is always shown above the line. So this is above, this side is above. So you have to read like this, it is 9. So this dimension is 9 actually. So from the top of the platform, if you moved by 9, if you come down by 9, you can see one edge not visible from the front. So it has to be shown hidden. So you have to come 9 from the top platform, right? So this 9 is the distance of the point, vertical dimension. So it is vertical dimension, right? So you have to move vertically down from the top of the platform by 9 mm and draw the first hidden line. So here let me mark a point 9 mm down, and by roller scale I will roll a line with the 9 millimeter point and neatly double trace. Okay, more length, less gap, more length, less gap. And you need to draw this hidden line till the end like this. So this is the first hidden line what we have drawn. Yeah, similarly, if you look at this diagram, you cannot see this edge going inside, the second edge. And if you look at the dimensions, if I erase a little, yeah, if you look at the dimension, from the top of the platform, it is 9 plus 9, 18. So if you come down by 18 from the top of the platform, you're going to get the second hidden edge of the slot. So there is a trapezoidal kind of slot. Okay. For that 1, 2 and 3 hidden edges are there. So the second edge is 18 from above or 9 from the first one. So let me mark 18. Okay, I'll align the roller scale with the previous hidden line. Roll and draw down. So I've drawn the second hidden edge. So be careful that the hidden edge should touch the inclined lines on either sides. Okay, the length should be more and gap should be less. Uniform hidden line. Finally, moving on. If you look at the platform, there are two more edges which is not seen from the front along X. The first is this one, second is this one. These two edges will not be seen. But out of these two, the bottom one will overlap with the edge of the object. So there is no point in drawing hidden line for the bottommost edge. But for this edge, you need to show hidden line, and that is 8 mm above. So if you move by 8 mm above, we need to show one hidden line like this. So see, even this is 8. So there is no need to measure again. We can align this part and draw a hidden line from ear to ear. So neatly double trace each and every hidden line. That is how this hidden line is ready. So by this, the front view of our object is ready. Okay. Now let us draw the top view of the platform. Okay, so for that, let me adjust a bit. Okay. So if you look at the top view of the platform, suppose if I remove the cylinder, you can see this rectangle first of all. So we need to darken this rectangle. Okay, its length is 50 and width is 60. So you have to look from top view from this side. See, X is here. So you have to look top view from this side. So these two lines will be the vertical lines which is 50 apart, and the rest is 60. So in this diagram, if you try to connect with this, let me shift a little. Yeah. So in this diagram, when you look in the front, you'll find this dimension as 60. Sorry, diameter 50. So in the top view, if you observe, this is 50 and the vertical is 60. So here from the center, if I switch over a little, I need to darken this full edge, but it should just touch the circle while drawing that dark line. And even over here, we need to align like this. So this platform, what is being drawn, let us try to find out from here. So see, this is the observer, right? So when you look in the top view, you'll find distance, you'll find some gap between the platform and the cylinder on the front and rear side. So this is the front side, this is the rear side, you'll find gap. On left and right, you'll find that it meshes properly. So left and right, it meshes properly. Okay, so that is the top side of the platform. Well, apart from that, the next thing is, in the top view, when you observe, you can see the inclined surface closed on all the sides by leaving a gap of 16. So from line of symmetry, it is 8 on either sides. So the slot is symmetrical, you can see very well. And the bottom edge is 16 mm wide, that much is open. So from line of symmetry, you have to leave 8 on either sides and close the platform. So this is our line of symmetry. You need to leave 8 up and 8 down. So let us mark 8 up and 8 down. And we will close these three sides. so as to get the platform correctly. So we will double trace this part. On both the sides. And even here we need to mark 8 and 8. So after the platform is almost ready, the only thing what is left is to complete this incline slot. So this incline slot we need to draw. For this incline slot, what is essential is, see, this dimension is 30, right? And if I name this point as 1, 2, 3 for example, and this is 4. So first of all, in the top view, you have to decide whether this 30 millimeter length of the line, will it be seen or not? The answer is yes, it will be seen, because this is inclined, and anything drawn on the incline will be seen. So this 30 mm length will be seen, and it corresponds to point number 1. And where is point 1 in the front view? Yes, it is the first hidden line. So from the first hidden line, this length corresponds to 30. So same thing over here also, if you have a look. Yeah, see, this edge is 30, isn't it? And let this be point number 1. So 30 corresponds to point number 1 in the front view, and in this front view, point number 1 is over. So this point is 1, isn't it? So clearly this shows that if I project point number 1, so the point number 1 is the intersection of hidden line and inclined line. So if I correctly project this one, so on this line 30 millimeter should lie. So from this point of symmetry, if I mark 15 up and 15 down, if I mark 15 up and 15 down, so that is how 30 I have drawn. Same thing you need to do on both the sides because of the symmetry. So the object is symmetrical. So same thing we need to mark here also. So this 30 mm is ready. So one thing to be noted, if you note down this dimension between these two dark lines, it is only 7, and in the question this is given 9. How come? So the point to be understood is this 9 is a vertical dimension, and then what is 7? So if you look in the top view from here, if you project this point and this point, so the projected length is 7, and obviously the projected length has to be less than the vertical length. See, vertical length is a true length 9, but the projected length is only 7. It is obviously possible. Now from point number 2, you can see this inclined edge on the inclined surface from the top view. This edge will be seen apparent. So the length of the line 1, 2 will be seen from the top. To try to visualize from top, project 1 and 2, you can see a small line, isn't it? So 1, 2 will be seen apparent in the top view. For that we need to locate 2. So this 2 is same as this point what I marked. So see in this diagram, this point is 2, isn't it? The same 2 is over here, the hidden line. So if you extend that 2 down, so from here, if you extend that 2 down on both the sides, and over here you need to darken the 4 ends. So I darken these 4 ends, and finally you need to join this. So let me use a scale. We can join this dark. Say I have joined this dark. So that is how this slot is ready. So this trapezoidal slot, what you can see here, which is of a huge size, is seen apparent in the top view. It is reduced. Hope the concept is clear. Now, as we discussed before, in the top view, if you look at this slot thoroughly and if you project this point down, you can see some portion of this slot, isn't it? So this edge will be seen up to some extent. This edge will be seen up to some extent, then you cannot see it. So from point number 3, this is a point number 3. From point number 3, some portion of this edge will be seen, remaining will be hidden, because the surfaces of its tapered nature will be seen from the top view. So from here, if you align these 2 points, okay, so you can see up to some extent, this edge will be seen up to some extent. From here also you can see that edge. Now we know that when dark and dotted line are in continuation, you need to leave some space. So see, there is a dark line over here, what you have drawn, because this much is visible. Now the edge will not be visible. So from here, when you draw a hidden line, you need to leave space. So I'll show you how to leave that space. So from this dark edge, leave space of 2 mm approximately, and then you have to start with hidden line like this. So on both sides you need to leave space, because when dark and dotted are in continuation, you need to make out the difference where the dark starts and where the dotted ends. So you can see it, look at this hidden line carefully. You can see there's a space on both the sides. This is to make out the difference. Same thing here also. From this corner, some portion of the edge will be seen on both the sides. Remaining, you need to leave some space and draw a hidden line like this. So from top view, these edges will not be seen. Which are those edges? So as per the question, it is this edge which is going inside and this one. Finally, you cannot see, look at this 30 mm what is written. So from point number 1 and 1 dash, you cannot see the edges going inside, isn't it? So this 30 mm line, from the top view it can be seen, no problem, no doubt. But from point number 1, there is an edge going inside on both the side. For that you need to show hidden. So if you look at these 2 points over here, from here, you need to leave space of 2 mm again and draw a hidden line. So total there are 4 hidden edges in the top view, what can be seen here and what we are drawing on this side. So even here you need to leave some space and draw a hidden line and draw a hidden line over here. So that is how the top view is almost done with these 4 hidden lines. So now the only view what is left is the side view of the platform looking from here. So from this direction, if you have view, we need to draw the side view of the platform. So if you try to visualize the side view, it's quite simple. Okay, so let me show some basic projections first of all. So in the side view of the platform, you can see 2 rectangles A and B. We can see 2 rectangles A and B separated by a gap of 16 mm, and the height is same as what is shown behind 8. So here you can see 2 rectangles like this. First one and the second one over here. Both are identical. Both the rectangles A and B are identical. So that is how you can see the 2 rectangles in the side. Now comes the inclined edge. So this inclined edge in the side view is seen as apparent. Apparent means reduced. So if you project this distance here, this height is the height of the inclined edge, which is smaller than the actual size. So it is called apparent. You can see this horizontal edge. Okay, so I have drawn the horizontal edge, and finally you can see the vertical edge over here. So these 3 edges can be seen clearly in the side view. Now comes the slot. The 30 mm edge of the slot, which is 9 mm below. So when you project that 9 mm from here, you can see that 30 mm edge of slot like this. You can see 2 inclined edges as a vertical line. And if you carefully observe, this inclined edge and this inclined edge, they are parallel to each other. So the projections also has to be parallel. So these two edges has to be parallel, because in the actual object both the inclined edges are parallel. Then you just need to connect this with 16 millimeter. That is how the side view of the inclined edge is being done. So now when we start with the side view, let us try to draw first of all these two rectangles. To draw these two rectangles, one must know the height and second is the width. See, when you look from here, this is the length, so this has to be width. So in the side view you can see width and height, correct? So we know that height of any surface you'll always get from the front view and width you will get from top view. So we just need to find out where is this height 8 mm in the front. So if you look at the diagram, that 8 mm is over here. This is that same 8 millimeter what we are talking about. So that 8 millimeter we need to project in the side view. So the correct word is project. So from here we'll project a light line in the side view like this. Now apart from that, we should also know the width of this. It can be easily found out by subtracting 60 from 16 and dividing by 2, but that will not solve the purpose of learning orthographic. So to learn orthographic, you should be able to identify where is the same width, you have drawn in the top view. So in the top view, if you look at the diagram, that same width is this edge. See, you are left 16 in between, 1 6, and this is the same edge, or you can say it is this one, or you can say it is this one. So I need to project this in between 16 in the side view. So from here, if I get this little down, I'll extend till 45-degree line, correct? And then from this side, that point where we marked, okay, we will project it up, and even from this side we will extend this up. So by this we get two rectangles of height 16. So let us make that dark, double trace and make that portion dark. So you need to carefully understand those lines. By mistake you don't draw the other line dark. Now remember that we need to leave a gap of 16 in between. So the remaining edge has to be darkened. Even here. So these are the two rectangles A and B, what can be seen from the side. The same rectangles A and B. Okay, here A and B can be seen from the side. Now next simple thing is, if you observe these three lines together, first inclined, second horizontal, third inclined, you need to close the box. That is the thing. So all the three edges will be seen. The horizontal line will be seen true length, means actual length. The incline will be seen little bit apparent. The apparent means reduced. Okay, so these three lines we need to close the box here. So if I from here, if I move up and close this box, I can see the inclined surface. So starting from here, we can extend this above, and finally I can close this rectangle. That is how I get the inclined surface, what you can see here. Now within this inclined surface, there is a trapezoidal kind of slot, what we need to draw. So let us see in the side view, if I need to draw line 1, 2. So suppose 1 is here and 2 is here. The width of the line is 30 millimeter. So you need to recognize this line from the front. So if you look in the front view, 1 and 2 will be seen as a single line, and that is 9 mm from above. So in the front view, we have already drawn a hidden line representing 1, and that is 9 from above. So this hidden line, I need to project it in the side view, and I know that 30 should lie here. See, one can easily measure 30 and draw a dark line, but here this 30 millimeter you need to recognize where it is in the top view. So in the top view, the same 30 is this dark edge. So I hope all of you can see that 30 mm, or you can see on this side, this is that edge of 30 millimeter. So that 30 I need to project till 45 and extend it above. So from here, let us do that. So this 30 millimeter, I'll extend till 45 degree line, and then from here, I will extend it above. So once you've done that, this in between edge is 30 mm. Okay, so that 30 mm is ready. Now apart from that 30, if you look at line 2, 3, so 2, 3 will be seen as a vertical line, isn't it? And that too apparent. It will not be of 9, it will not be of this inclined line. So the inclined line will not be of the same length, because the projection of the inclined line is a vertical line which is 9 millimeter long. And that same edge is over here, the second what I have written here. So when we extend this, and so we can darken this portion and even this one. Finally, to close down the slot, this edge or this corner has to be connected with another corner of 16 mm so as to get the trapezoidal slot. So just we need to connect or join these 2 points, and here we need to connect these 2 points. So that is how the trapezoidal slot is done. And if you carefully observe the diagram, when you look in the side view, the front half of this diagram is symmetrical with the rear half. So what is happening is there are no hidden lines, because all the edges in the rear side overlaps with the front edges. So there is nothing like hidden line to be drawn here except this surface what we done before. So except this cutout or slot, there are no hidden lines in the side view. So that is how we have completed this part. Now before we started the dimensioning, what is left is to draw center lines and axis line. So starting from top view, see we have drawn a circle here. So it is compulsory that wherever you draw a circle, you need to represent the circle by a center line. So this was the center of the circle, isn't it? So from here, if I mark a medium dark plus sign, so this is the smaller line of the center line. Next you need to align the scale and draw big dash and small dash. Remember that it should slightly come out of the circle. The center line is a bit bigger than the diameter of the circle. So slightly should come out from all the sides. So that is how center line is drawn. Now if you look in the front view, see this gap between the 2 dark lines represent a circular surface or a cylindrical surface. So for that we need to show the axis. So if I ask you what is the height of the cylinder, it is not throughout, it is only from here to here. So the axis line should be shown in and around this line. So you can align the scale, and you can show big dash and small dash over here. So that is how this axis is shown over here. Finally, looking into the side view, even this surface is a circular surface. So if you look at the question here, this surface is a round surface, and round surface should be compulsory shown by axis. So this surface is fully round. So if you need, you can mark the midpoint of 20, say 10. Instead of projecting, you can do it like this, and then you can align the scale and draw big dash and small dash just in and around the cylinder. So see, cylinder is only till here. You might extend slightly below, not throughout, and here slightly above. So this axis represents a circular surface. I hope all of you understood why I have shown the axis vertical and why not horizontal. So in the diagram, if you look at this cylinder actually is a vertical cylinder. It's a standing cylinder. So the axis will also be vertical. So therefore, this axis is vertical over here. Okay, so that is how we have completed the 3 views. But as all of you know that without dimensioning, the drawing has no meaning. So let us start with the dimension part. So the first important dimension is the length 90 millimeter. And along with that, while showing width 60, it is advisable to show 16 also. So remember, whenever you want to show 2 dimensions, one above, one below, always show smaller first, followed by larger one. So we'll first show length 90. Okay, so length 90 can be shown in the front view. So here I will draw medium dark extension line on both the sides, leaving a gap of 2 mm. And then from here we can show dimension line neatly. Arrow mark as thin as possible. Arrow mark is the maker. Your drawing maker is the arrow mark. It can spoil the drawing or it can make your drawing. It depends on you. So length is done. Now as I told you, width, there are two entities, 16 and 60. So we need to spread the dimension in all the views. All of you know that. So one can show 16 and 60 here. We can show 16 here followed by 60. So that can be shown together. Okay, so let us show smaller dimension first, 16, followed by larger dimension 60. And always show dimension above the line. Okay. So here, after you have shown both the dimension lines, so carefully look here how to show the dimension. So here we can show the smaller dimension as 16. So see, I am not adding or subtracting dimension. I am not creating any dimension. I am only showing those dimensions which are given in the question. So in the exam you are supposed to do the same thing. You prepare the drawing on AutoCAD software or manually. The concept remains same. That only show those dimensions which are given in the question. Do not add, do not subtract, or do not create dimensions. So see, length is done and width is done. Now height of the object. So height of the object, they have not shown 86 together anywhere. They have instead splitted the height into two parts, 54 and 32. So we can show both these dimensions in the front view, okay, or in the side view. Both are acceptable. So here, so this dimension is 32, the platform is 32 and that is 54. So we can show the dimensions or split or put into one part. So here, so the platform height is 32. We can show 32 from here to here. Okay. So we can show 32 here. So this height, but 32 alone will not give you the complete height of the object. We need to add 54. So for 54, we can show in the side view also. So we are allowed to split the dimension in multiple views. So 32 I have shown in one view, or else you can even show 54 here, no problem. So there are multiple options, we are exploring all of them. So 54 is done. So when the reader wants to know the height of the object, he or she will add 54 plus 32 and get the total height. So length, width and height is done. Now count the number of dimensions. 1, 2, 3, 4, 5 are shown. There are 5 more left. So one of the dimension what the examiner expects is to show the diameter of the circle. So whenever there is a circular part, the examiner expects that you at least show diameter or radius. So in the question they have shown diameter. So you are expected to show diameter only. And diameter you have to show in that view where circle is drawn. So you can see there is a circle of diameter 50. So you can just place the scale diagonally and extend the line out. See, like this. You have to show arrowhead pointing the circle on both the ends like this. Then parallel to the length by roller scale, parallel to the length. Don't forget to draw a horizontal line and write 550 over here. So 50 is the diameter of the circle. So we have shown 6 dimensions till now. 4 to 5 are left. Now let us see one new way of dimensioning. So if I erase this a bit. Yeah, this 9 millimeter is from the top of the platform. Then again 9 till the next edge. So I need to show this 9 and 9 together. So as I told you, you should avoid showing dimensions from a hidden line. So it is advisable to show 9 mm in the side view. So how to show 9, all of you carefully look here. So suppose if I want to show 9 on this side, the first extension line from here. Now, so I will zoom a little. Now this height is 9. So the object line of 30 millimeter ends here. You can see that. So from here you have to leave a gap of 2 millimeter. So remember, don't leave gap from here. If you look gap from here, you won't understand where is this 9 from where to where. And if the same gap is left from inside, now it is much more clear that 9 is from here till here. So always you have to leave 2 millimeter gap from where the object line ends. The next 9 millimeter is on this side. Now what you have to do is that from here you need to leave a gap. Okay, now the problem is if I show arrowheads inside, it is possible that because this gap is less, the arrow marks might collide with each other. So one new technique of showing dimension is you just extend this line and show arrowhead pointing inside. So as you can see here, you have to show arrowhead pointing inside. And in between there is no space to show arrow mark, so you can draw one inclined line like this. And then you can write 9. If you're not comfortable enough to write 9, you can write 6 in opposite direction. So it looks like 9 only. See, I have written 6, but actually when you read about the line, it is 9. I hope the things are clear. So let us hunt for few more dimensions. So after that, 38, 21, 20 is left. 24 can be shown. Okay. So let us show 24 in the front view. Okay. So here we need to show 24. So we will extend this up. Extension line. And then we'll show a neat dimension line. We'll show the arrow mark like this. When you write 24, you should be aware of 4. So 4 should be written compulsory like this as per ISO standard. So if you look at the scale, 4 is shown like this. So as per ISO standard, we are showing the 4. Now if I count the dimension 1, 2, 3, 4, 5, 6, 7, 8, 9. So one more we need to show. One more dimension. So in the front view, this height is given as 38 in the question. So 38 is shown here till this edge. So here we need to show 38. So leaving a gap of 2 millimeter. Now 38 can be shown inside the box but not inside the object. So see, object ends here. You can show anywhere outside, but it can be shown inside the box also. So 38 can be shown like this. So dimensions you are allowed to show within the box but not inside the object. Don't write 38 inside the object here. Everything should be outside, object should be clear. So that's how I have completed all the 3 views with dimension. There is no need to write front view, top view, left hand side view, right hand side view, nothing to write. You have to present the answer like this only. Okay, so this is the complete solution